Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT MS, ISI MStat, and CMI MSc Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses.
Let f be a function which maps from 0, 1 to 0, 1, be a continuous and such that f of 0 is equals to f of 1. And let A be the set of all ordered pairs of t comma s in this Cartesian product 0, comma 1 cross 0, comma 1. Basically, the t comma s, this ordered pairs. That means t and s can be anything in that square region, right? In that square unit square, such that t is not equals to s and f of t is equals to f of s. The number of elements in A is 1, 2, infinity, and none of the above. So, what is the correct option? So, we can you understand? It basically says that f maps the domain is 0, 1 and the codomain is again 0, 1, and the function f is continuous. And it is also said that f of 0 and f of 1 are same. So, basically, A is the set of all those points in that 0, 1 interval for which the functional value is the same. It just says that. For example, it already contains 0, comma 1, right? Because at if at 0 and at 1 both the functional values are the same, it is given, right? So A already contains the point 0, the ordered pair 0, comma 1. Elements in A is already at least 1, we know that. So does A contain more than 1 points? That's the question. The number of elements in A. So how do we approach this problem? So it is a very kind of easy problem. We can easily take a few examples and see. But the thing is, again, I have to show a better way of solution, right? So this is the solution I have made. So f maps from 0, 1 to 0, 1, f is continuous, and f of 0, 1, f of 0 is equals to f of 1, right? So I'm taking the non-trivial case. Obviously, the trivial case being that f is a constant function. Suppose f is equals to half for all x, right? In that case, if you see, in that case, f of 0 and f of 1 are both same, right? They are half. And in fact, in that case, if you take any 2 points in that interval 0, 1, they will always have the same number, the same value, functional value, right? If you take f to be a constant function, suppose f of x is half, then f of 0 is half, f of 1 is half, and if you take any number between them, say f of 1 by 3, that is also half, f of 1 by 4, that is also half. So basically, you can get uncountably many points at which the function is half. So in that case, the set A will have infinitely many elements, right? So just checking that one function, we can easily think that it is infinity. But still, we have to have a general solution. So let f be a non-constant function, right? So therefore, there must exist some point alpha naught in between 0 and 1 such that alpha naught is equals to k and f of 0 is f of 1 is c, right? So I'm assuming that f of 0 and f of 1, they are both equals to c, and I'm assuming that since f is a non-constant function, therefore there must exist some point alpha naught in between this open interval 0, 1 such that f of alpha naught is k, but k is obviously not equals to c because I am assuming that that point alpha naught assumes some value different from c, right? So this is the thing. I'm assuming that. Now consider this point, this interval 0, comma alpha naught. This the basically I'm just dividing the entire interval 0, comma 1 into two intervals, two sub intervals 0, comma alpha naught and alpha naught, comma 1. So first interval is this 0, comma alpha naught. So clearly f of 0 is not equals to f of alpha naught. Why? Because f of 0 is equals to c and f of alpha naught is equals to k, and I've already said that k is not equals to c, right? So they are different values, right? So by the Bolzano's intermediate value theorem, or BIVT for short, if you know the intermediate value theorem, if you don't know, that's fine. That just says that if a function f is defined on an interval, any interval, and if you take any 2 points a and b, and if f of a is not equals to f of b, right? Different values, then for any value k in between f of a and f of b, there will exist some point c in a and b such that f of c is equals to k. And if has to be a continuous function, of course. Other than that, that wouldn't hold, obviously. So suppose that intermediate value theorem is a very simple theorem actually, but very powerful one. So it says that since f of 0 and the function is obviously continuous, right? So in this interval 0 comma alpha naught, obviously this function is continuous, and f of 0 is not equals to f of alpha naught, right? So by the Bolzan's intermediate value theorem, if you take any point u in this interval f of 0 and f of alpha naught, there exists some point v in 0 and alpha naught, right? Thus that f of v is equals to Bolzan's intermediate value theorem is basically given in the Bartle-Schubert book. You can just refer to that book. It's very nicely written and understood, explained. So Bolzan's intermediate value theorem, I'm again repeating. It basically says that if f is a continuous function on some interval I, and if you take any two points a and b, and if they have distinct functional images, that means if f of b is not equals to f of a, right? Distinct values. Then if you take any number between f a and f b, there exists some number in a and b such that the image of that number is k, right? That's the thing. So basically, I'm just using that. So since in this interval 0 comma alpha naught, f of 0 and f of alpha naught are distinct, obviously, as I said, k is not equals to c. So by the BIVT, if you consider any real number u in this interval f0 and f alpha naught, there exists some v in 0 and alpha naught such that f of v is u, right? Also, for the same real number u, consider the interval alpha naught comma 1, right? Again, alpha naught and alpha 1 are again distinct, right? So it is this alpha, f of alpha naught is k and f of 1 is c, so they are distinct. Again, for this same u, again we will get some number, some number w, right? For the same u in f of alpha naught and f of 1, some number w in alpha naught comma 1 such that f of w is u, right? The same number. I am using the same number u for that first interval 0 comma alpha naught and the second interval alpha naught comma 1. So for the same two intervals, I'm using the same number, and for that in this interval I am getting a number v 0 comma alpha naught in this interval, and in this interval alpha naught comma 1 I am getting another number w, right? Clearly v and w are distinct numbers, right? Because v belongs to this interval 0 comma alpha naught and w belongs to this interval alpha naught comma 1. So v and w are distinct numbers. So if I take, that means if I take any number u, right, between these things, between c and k, I will always get at least two numbers between in the interval 0 1 such that both of them have the same value u, right? Functional values. That means since u is infinitely many choices, obviously u has infinitely many choices, right? Because k and c, they are distinct numbers, and therefore they have infinitely many real numbers in between them. So you can be any infinite in any number, right, in between that k and c. So, and for each of that number, each of the choices, we have a pair v and w, right? For which the functional value is same. F of v is w, f of sorry, f of v is u, and f of w is also u. So I'm again repeating. Since k and c, I've already assumed that k and c are distinct, and since they are distinct, they have infinitely many, uncountably many real numbers in between them. See, if I take any real number u in between them, I'll always get at least two numbers v and w, such that f of v is u and f of w is also u, right? So for any such choice, I'm getting two real numbers, at least two real numbers, in fact, for which the value is u, functional value. Therefore, the number of such pairs t comma s for which f of t is equals to f of s is infinity, right? Because u, as I said, u has infinitely many choices, right? And again, if I take k equals to c, that just becomes the constant function, and for the constant function, you can easily check that it has infinitely many values, right, in the set A. So the option C is actually the correct answer, infinite. So A has infinitely many values, right? So yeah.
To book a trial class for your preparation courses of IIT MS, ISI MStat, and CMI MSat Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.